Today we're going to be talking about the basics of your first AI project. Let me rush through really quickly one assignment I did, training a neural network to distinguish between Wat Phra and Wat Po. If you're from Thailand, you know these are two of the most famous temples in Bangkok. There exist thousands and thousands of photos for these two temples on the internet. So how do we get started? Let's assume you're given nothing. Starting from scratch on a new project can be frightening, but it also gives you a degree of freedom. Breaking down a problem will let you know that we need data. So I made a scraper. A scraper or a scraping script is a mini program that one writes to pull free range data on the internet. Mine is written in Python and it allows me to automatically save images from a Google search using the query that I give it. Let's begin.
Leute, ich bin der erste Rapper mit Inhalt und Message. Es geht um Drogen, Huren und immer um Meckes. Rapper machen Ansagen und Absagen mit Tracks, die klingen wie schwanzblasende Balladen. Stoffticken ist die Basis für Rap-Singles. Du kommst mit Punchlines, ich aus Maastricht mit Stecklinge.
You can see like the process going on in the background here, and now it's just finished. So actually it's only half finished because first of all we get all the images and we now have to start downloading them one by one, and I put it right here in the data folder, and you can see it expanding in the background because we are now one by one downloading all these images from Google search, like so. Next, we move on to scraping images from Wat Phra itself. I've set my scraper to save 200 images for each query, but a normal training requires a much larger dataset. We're not doing that today since I can't show you how boring it is, and the quality of images decline the larger that number is. I'm not talking about photos resolution, but relevance itself. Let me see if I can find it. For example, in the last dataset that we found, I'm just gonna scroll down, and you can see like the photos that we've attained so far. But some of the photos that we attained from the Google search is not so relevant to the project. For example, this one is just a map, and it's very hard to see any distinguishing feature of that temple itself to be included in this photo. It might be the map of that temple, but it could be found anywhere else. Secondly, in this one is a third temple that is neither Wat Phra or Wat Po. So this one is going to affect the training data, but looking at this, I think it might be interesting to include in the training data set that we have today. Let's see where we are on the scraping.
Plastiktüten mit Hanfblatt und Zipverschluss. Irgendwie macht man durch Straftaten immer Plus. Wen juckt deine Meinung, Hure? Beschwerst dich wegen Style und Coolness, Reimstrukturen hab. Zerknüllte Batzen statt goldener Mastercard. Bums deine Mami, weil heute ist Vatertag. Fress mich voll mit Aioli und Tapas-Schalen. Pflanz mit Ruggerpaten, ganze Grasplantagen. Ich hau auf deine New Era Cappy und du sagst, ich find dein Fuß lecker.
Now that we have both data sets, let's get to see the machine learning code itself. First, we have to bring in the images that we saved. I'm using a library here called Keras. Keras is an open source neural network library written in Python. I wrote a little function here that shows how the images are represented within the notebook itself. As you can see, they're in grayscale. That's because I decided to move dimensionality from our training data so that we can train faster. The assumption we made here is that the color between the two temples are not the distinguishing feature between them. If you're doing a project to tell the difference between two differently colored items, you might want to leave that in. Next, we see the layers of the neural network. I'm adapting a popularly used convolutional 2D neural network framework, often used to distinguish between photos of cats and dogs. When looking at the neural network training, you want to look at the activation function here and what is being done here to avoid overfitting. And then we have the output layer. Before we train, Keras give us a simple summary to show us the parameter count of each layer and let the training begin. This is what it looks like post-training. I'm using epochs number here of 30, which means that we run training over the same data set 30 times from different angle. Let's see the training result about how well it does. First, we look at the result at training data itself, which means that how well the convolutional neural network can tell the photos within the training data, and it's doing really well. It's doing 10 out of 10 answer correctly, which means that in training data, we're doing fine. But that is not how you want to judge a machine learning algorithm. In order to judge a machine learning algorithm, you want to see the result about how well it does over test data, which is a data that you've never included within the training itself. But when we go to the bottom here, I've arranged 8 images that are just not in the training data at all, and see if it can actually do the same thing there. And it does pretty well here, except for these 1, 2, and 3 images. What that means is that like my trained model here actually can do 5 out of 8 images guessing correctly, and the prediction model here can actually be have its result metrics shown, as you can see in the bottom here. Since it's a binary classification problem, I've done 2 types of metrics showing, which is basically the floating point errors type or the binary classification errors, and it's okay. You don't actually look at the how many times it gets correct. You look more so on the errors. So as you can see, this is the end of the example that I brought up here, and this is part of what a machine learning model can do, how an AI can actually distinguish between 2 items essentially. And that's only one problem that you can see. What it can do is a lot more than this, as long as you have the right methodology or the right data to do so. There are many types of AI, and this one is binary classification AI. And there you have it. That's how you train your AI. And this is just simply a binary classification problem. But when you've seen how the flow actually go for this problem, obviously I did not go into the language or the libraries that we're using too much here, but we go through like basically how do we actually get data, how to actually set up the project, and what are the metrics that we actually evaluate the problem, the answer to the problem. And that's how you essentially go project by project and try to deduce the right solution.